Hello everyone, this is Mr. Appel, and here's another example of graphing in phases. So this time we have this function here, negative parentheses x minus 2, all cubed, plus 4. So the first thing to do is to recognize the parent function, which is cubic. So this is a cubic parent function. So we're going to start by graphing that parent function, which is just y equals x cubed, or f of x equals x cubed. And again, at this point, you should be familiar enough with the, oops, sorry, I switched to y there instead of f of x. I don't know why I keep doing that. Either way is fine. You can write it as xy. Actually, it doesn't make much difference. Okay, so cubic parent function. Let's just pick some key points. When x is negative 2, y is negative 8. When x is negative 1, y is negative 1, 0, 0, 1, 1. And 2, 8. And again, you should be that familiar with your parent functions that you just kind of know those numbers, or you can figure them out pretty easily, right? Negative 2 cubed is negative 8, and so I'm just getting these by using that parent function. Okay, so I'm going to go ahead and graph those. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8 is down there. Negative 1, negative 1, 0, 0, 1, 1, 2, 8. And this can be a little tricky to graph and make it look nice. Just remember it is supposed to be curvy, so just do the best you can to show that curve. It doesn't have to be perfect, but it should look curvy like that. Okay, now I'm looking at that function, and remember you kind of use order of operations to decide what's next. So inside the parentheses is that minus 2. That minus 2 is a translation right 2 units. Remember the h is actually, since it's x minus h, it's actually 2 to the right. Whoopsie, didn't mean to do that. And so, whoa, I'm moving everything around here. Technical difficulties, but that's okay. Let's try it again. So we're going to identify the transformation, which is translation right 2 units. And then we can simply take each of those points and slide them over too. And I'm going to go ahead and list our coordinates. And you can kind of do it on the graph and then write the coordinates, or the other way around. But if we go right 2 units, you may remember from transformations in geometry and in your work here, the x value changes, the y value stays the same as we go left or right. So if I go right 2 units, we're adding 2 to each x value. So we're simply taking this graph, this table, these values, and adding 2 to each x value. So instead of negative 2, negative 8, it's going to be 0, negative 8. Negative 1 plus 2 is positive 1. 0 plus 2 is 0. 1 plus 2 is 3. And 2 plus 2 is 4. And so all I did again is just add 2 to each x value, kept the y value the same, and that has the effect of moving everything 2 units over. So 0, negative 8, 1, negative 1, 2, 0, 3, 1, and 4, 8. And so again, I'm going to kind of zoom in so I can try to make it as curvy as possible. Oh, that's not bad. Pretty good, Mr. Appel. Well done. Okay. Next phase is, I'm looking over here, so we did inside the parentheses, so now we do multiplication, which is the thing outside or right in front of the parentheses. In this case, it's just a negative. It's like a negative 1 multiplied by that. So in terms of transformations, that's a reflection, an x-axis reflection. So I'm going to label that x-axis reflection. X-axis reflection. And if you remember, hopefully from geometry and again from your work here, when you reflect over the x-axis, the x values stay the same and the y values simply change sign. So the x values stay the same. Whoa, sorry, having some issues here. So I'm going to just recopy my x values because they're going to stay the same. And my y values from the previous phase are just gonna flip-flop. And so negative 8 becomes positive 8, negative 1 becomes 1, 0, 0, negative 1, or 1 becomes negative 1, and 8 becomes negative 8. going to go ahead and plot those, and we should see the mirror image of the previous phase. So 0, positive 8 is up there, 1, 1, 2, 0, 3, negative 1, 4, negative 8. And so we see that reflected. Ooh, that one got a little ugly because I didn't zoom in, but that's okay. Because I marked those points there, even if you miss them a little bit on your paper, it's not the end of the world. Try to make it. Actually, that's bothering me. So I'm going to try to, whoops. I'm going to try to, whoa, no, what happened, Mr. Bell? Fail. There we go. I'm going to try to fix that a little bit because it's bugging me. I'm going to just make that a little bit better. That's a little better. Okay. And finally, the last transformation that's taking place is that +4. It's after the parentheses. It's after the cubing, after the negative. So adding and subtracting when you're thinking order of operations. +4 is a translation up 4 units. And so if we're looking at the original or the previous x and y values, we're going up 4 units. And so up 4 units is just adding 4 to each y value. You may remember that again from geometry or from your work here. So we're going to add 4 to each of those y values. So 8 plus 4 is 12, 1 plus 4 is 5, 0 plus 4 is 4, negative 1 plus 4 is 3, and negative 8 plus 4 is 4. And again, sorry I wasn't kind of highlighting this, but I'm just adding 4 to each of these y values because of that up 4 transformation. Now the 0, 12 is going to kind of go off my graph a little bit, so I'm just going to kind of stick it up there in the air. 1, 5 is there, 2, 4, 3, 3, and oops, that was supposed to be 4, negative 4. And by the way, if you make a silly mistake like you just saw me almost make there, where I forgot to put the negative there, please don't say, oh, well, it's 4, 4, so the point is right here. You should look at that and see that can't be right. It doesn't look like our cubic function anymore. And then you should be able to fix that mistake. Okay, so 4, 1, 2, 3, 4. Now I see that cubic shape reflected that we're expecting. That one's always tricky to draw, but there it is. And that is that function graphed in phases. That's all for now. Thanks.